Okay, so we are on part 3 of our ionic nomenclature journey. This is becoming quite the journey. This is the last new information that we're going to learn, and then we're going to spend some time like practicing it over and over and over again. So what we're introducing on page 3 of our nomenclature practice is it says transition metals. Now if I'm just kind of glancing down here, I'm starting to see these Roman numerals pop up again. Luckily, I think I alluded to this in some of our previous pages, that those Roman numerals on the back of my booklet, they tell you what those numbers represent. Those are the positive charges of some of my specific elements that are transition metals. And let me be clear, when I use the term transition metal, I know y'all are thinking, those are my D block elements. And yes, they are, but I made this little thing. This is a very ugly periodic table that I've colored 1,000 years ago, but it still works for us today. So, when I say transition metals, I'm meaning anybody but group 1 and group 2, and then silver, zinc, and aluminum. Everybody else that I have colored here, which is very difficult to see in the orange, they will require a Roman numeral. So when I use the term transition metals, that is what I'm collectively looking at here. So yes, my inner transition metals, my transition metals, everything underneath this staircase, basically this entire section, do not include group 1 and group 2. Do not include silver, zinc, and aluminum. These guys are good. These guys are easy, okay? Everybody else requires a Roman numeral. So that's what I mean when I say transition metals. I may get this out a couple of times if you guys need some help. So we will be using our colored periodic table. We will be using our nomenclature foldable. We will be using probably our polyatomic ion list. We got a lot of tools for us today. And our red and blue colored pencils, because I find that to be very helpful and fun. Okay, so we are ready to go. Once again, an ionic compound is always made from a metal cation and a non-metal anion. 2 things, a red and a blue, okay? So I'm going through, I'm going to go look through my 2 things. Now, lead, yeah, that's absolutely a metal. He'd be right here, PB, right? Lead 2, that means this lead has a +2 charge no matter. I'm just underlining things now. That is absolutely a metal. Yes, positive guy. Iron 3. Yep, iron's right there. The only reason he has this 3 is because I need to let you know what that charge is. He's not in group 1 or 2 and not silver, zinc, or aluminum. Copper 2, nickel 2, tin 2, chromium 2, zinc. You're like, why does zinc not have something fun for me? Well, zinc always has a +2 charge. This is very interesting. When you see zinc, I'm going to assume that you know he's got +2 charge. That's what that arrow, +1, +2, +3. Chromium 3, yep. Tin 4, yep. Silver always has a +1 charge. Okay, so yes, I have not done anything sneaky. These are all metals starting off first. These are ionic compounds, which means I'm assuming that everything on the end here is either a simple non-metal from the periodic table or a polyatomic ion with a negative charge over here that is acting like a nonmetal. So let's see. Chloride. When you see IDE, your brain thinks, yo, this periodic table. Yeah, chlorine. Nitrate, 8888, is a polyatomic ion. Phosphate, 88, is a polyatomic ion. Oxide is oxygen. Fluoride, ide, is fluorine. Acetate means 888, got to be a polyatomic ion. Zinc nitrate, 888, polyatomic ion. Nitride, that's just plain old nitrogen. Nitrite, is a polyatomic ion. Where you go? Nitrite, there we go. Okay, I love these 3. Nitrate, nitride, nitrite. The 8 and the ite endings are polyatomic ions. If I see IDE, that usually means I'm dealing with somebody over here. Except, let's look at this last one. Cyanide. You're like, great, it is something from the periodic table. You're looking for cyano, it ain't gonna help you. There are a couple of polyatomic ions who end in IDE, specifically cyanide and hydroxide. So you do have to kind of keep your eyes open for that. Once you get used to using these polyatomic ions, it will become a little bit easier. Okay, so cyanide. Great, I have a red thing, I have a blue thing. We are excited about that. We are now ready to write formulas for these guys. Okay, The only sneaky business here is that charge, or that Roman numeral, represents its charge in parentheses, or it represents its positive charge right now, okay? So we have lead. Lead's symbol, I'm going to zoom in a little bit. Lead's symbol is Pb. And I'm telling you he's got a +2. Chloride is plain old chlorine. Chlorine with a -1. I'm going to crisscross these down, which means that lead's 2 gets dropped down as a 2 subscript behind the chlorine. So I have PbCl2. Okay, iron with a +3 charge. Nitrate, polyatomic ion. Remember, polyatomic ions in parentheses. NO3 overall has a -1 charge. Take those numbers down. I have 1 iron then, and I have 3 nitrates. Cool. Copper with a +2 charge. Noticing each one of my Roman numerals, these are for metals, so they've got to form those positive oxidation numbers. They're gonna lose electrons because they're cation, so they always are plus. Phosphate, polyatomic ion in parentheses, PO4. He's got a -3 charge. So that means there's going to be 3 coppers and there's going to be 2 phosphates. So I got Cu3, PO4, 2. Once again, if I'm dropping those subscripts down, do not interrupt the polyatomic ion. It is good and fine there for me. Okay, nickel. Nickel's got a +2. Oxide, that's plain old oxygen with a -2 charge. I got a 2-to-2 ratio. That would normally look like Ni2O2, but that 2-to-2 ratio I can reduce down. So it is a 1-to-1 ratio. Okay, let's see what other one I want to do here. Let's do silver cyanide down at the bottom, number 10. This is a new one, kind of a new little polyatomic ion that we don't commonly use. But silver, I don't have a Roman numeral for him because you know that if he is silver, he's got a +1 charge. So silver is a +1. And cyanide, polyatomic ion. Cyanide is, I got lots of papers here. Cn with a -1 charge. Yes. So it is just AgCN. And once again, do not be, you can totally leave that polyatomic ion in parentheses, even if you only have 1. That is fine. It makes me a little bit more satisfied too, especially when I'm just getting started. I want to do maybe one more. I want to do one more. Maybe. I don't know. Yeah, let's do lead 4 sulfide. Lead's 4 sulfide. So this is Pb with a +4 charge. Sulfide. Sulfide is plain old sulfur, who's got a -2 charge. Okay, let's see. So after I crisscross those numbers down, I have Pb2, S4. I have a 2-to-4 ratio, which, yes, can be reduced down to a 1-to-2 ratio. So once again, reduce your subscripts if you need to. Cool. Okay, I want to hop on down and do the naming. That I feel like the writing formulas for transition metals is kind of a little bit more easier than what you were maybe anticipating in your body of being stressed out. The naming stuff can be a little bit trickier. So once again, I brought this real ugly periodic table out. This is so important, you guys. When I'm naming things, don't you dare put a Roman numeral unless I am in this orange area. Okay? If you are in group 1 or group 2, if you are silver, zinc, or aluminum, you just name those elements and then move on to whatever your anion is to name. But if I am in here, you need to figure out what the charge is of that transition metal and represent that in Roman numerals inside of the parentheses. You were like, how am I supposed to do that? Well, let's look at our naming booklet on what they have to say about transition metals here. So it says when we name the cation, we're not going to be dealing with a group 1, group 2, silver, aluminum, or zinc, right? We're going to be dealing with the transition metal. It says use the element's name and the charge in Roman numerals in parentheses. So that's documented in your naming book too. Okay, so let's get to this example. First, let's double check, make sure we have a red thing and a blue thing. Copper, yep, he's a metal. Chlorine, yep, he's a nonmetal. Iron, yep, he's a metal. Oxygen, yep, he's a nonmetal. Tin, yep, he's a metal. Oh my gosh, lots of things. Oh, it's already got parentheses. Sulfate, he is a negative polyatomic ion. Nickel, yep. Fluorine, yep, looking good here. If you'll also notice, just kind of glancing down this list, I have maybe a few polyatomic ions that do not have parentheses, but could probably benefit from some parentheses to help me feel a little bit more safe and secure that when I get to them, I'm just naming the 2 things I see. Right? So if you see any letters of, or any formulas that have like a lot of letters of the alphabet going on and they don't already have parentheses dividing up the polyatomic ions where you see it, go ahead now and like crank that out, because then you can see the 2 things that you need to name. Okay, cool. All right, let's see. So I'm getting ready to name my guy. I'm very excited. The way that I do these is I make the Roman numeral figuring out like the last thing I do. I, as fast as I can, write down the 2 things that I see, and then I come back and I ask myself, metal, do you need a Roman numeral? And then if he does, then I work out in my brain and have to do the puzzle that may be required to figure out what his charge is. So the 2 things that I see copper, which yes, he's a transition metal, but I'm gonna leave a space here. And then I'm just gonna, as quick as I can so I don't have to think and worry about him. Name the other guy. That's chlorine, so chloride. Copper, chloride. I left a little space. So yes, he's a transition metal, right? Where is he? Right there. So I will need a Roman numeral for him. Now I just need to figure out, well, what's his charge? Well, let's look up here where we created formulas for these guys. Y'all, we took those charges of these transition metals and they always turned into the subscripts, right? So what we can actually think about doing is doing a reverse crisscross, right? Grabbing what the subscript is down there on the opposite anion, pulling it up and being like, well, that came from whatever the positive of that transition metal was. So looking at this, I'm like, yo, look at that 2 underneath that chlorine. Y'all, I bet that came from copper's +2 charge. Now, the reverse crisscross has to apply for both. So what that means is you're always going to want to check whatever the other subscript is and confirm to yourself that that makes sense for the anion that he is paired up with. So that would have meant that that chlorine had a 1 or a -1 charge. And you're like, yep, he is in absolutely that group that would make a -1 charge. So that makes sense. But what I'm getting from this is that guy right there, that +2. So I will write a 2 as a Roman numeral in there. Okay. Now I'm already going to scare you with this second example. It's fine. Okay. Iron oxide, right? Ooh, I'm already getting red flags about iron. Yep, probably going to have to deal with that, but let's go ahead and name oxide. Oxide, right? Single elements, we change the ending to I, oxide. Okay, now we'll go back here. She says the reverse crisscross. We'll pull the reverse crisscross. Well, these are 1s, right? Cool, so your brain is thinking that is iron with a +1 charge, right? This is where I mentioned having to check on the other subscript. That would have been telling me that oxygen would have been pulling a -1 charge. Well, I will, under all circumstances, know what the charge is of any nonmetal or a nonmetal acting polyatomic ion. That is not something that I will ever have to figure out or not know. I can check my answers on that. Specifically, oxygen, he's going to have a -2 charge. So what the heck is this? What is going on here? This was a reduced down ratio. Y'all, oxygen had to have a has to. So that means in order for this ratio to be reduced down to a 1-to-1 ratio, that iron has a +2 charge. Okay? So what this initially looked like was Fe2O2. That we've practiced this before, we would have erased, and that's how you get that. So it is a reverse crisscross, but you gotta apply it for both and check that anion to make sure the charge on him makes sense based off of what you're seeing, to catch yourself to see if it's a reduced ratio of the subscripts. Okay, let's see this one. Oh my gosh, speaking of, here we go again. Yep, we're going to do it. We're feeling brave. We love this. That's tin. We're like, okay, you will need a Roman numeral, so we will come back to you. And who is that? Sulfate. Polyatomic ion sulfate. Once again, just name your polyatomics. Don't worry about them. All right, figuring out what his charge is. Reverse crisscross, right? This was a 1:2 ratio down here, right? Which means we're thinking tin had a +2 and hoping when we check that sulfate had a -1. But when I check sulfate, a reduced down ratio again. This has to be a -2, which means for it to have gotten reduced down to a 1 here, this was originally a 2:4 ratio. So this is 10 with a +4 charge. Y'all, that was a very, very difficult one. Y'all are like, what are we even doing? Most of these problems are not reduced down ratio mystery puzzles. Most of them are a little bit more standard, but I did want to put these on here so you guys are just kind of, you know, keeping your eyes open for them. Okay, next guy. I've got nickel. Yep. Transition metal, he will require a Roman numeral. We will leave space for him, but the second guy, I want to name him. He is fluorine, so plain old fluorine is fluoride. Yep. Okay, I got to figure out what the nickel's charge was. I'm thinking that 3. Maybe he had a +3. Let's check just to make sure. That would have meant that the fluorine had a -1 charge. I can check that. Yes, okay, not a reduced down ratio. That is a true +3 charge. Last one I thought we would do together is this one. So this is chromium. I'm like, oh my gosh, where is he? He is right there in the middle of the transition block. So he's absolutely going to need chromium. Sorry, I can't talk and write at the same time. Going to need something to tell me his charge there. And then polyatomic ion nitrate. Yes. Okay, reverse crisscross. Let's see what mysteries there may be. This was a 1:2 ratio, which would mean chromium +2, nitrate -1. Does nitrate have a -1 charge? Does he have a -1 charge? Yes. Okay, so this is truly chromium with a +2, or chromium 2 nitrate. Okay, we did a little bit of a lot. So there are a lot of metals who could potentially need these Roman numerals, like a lot of them. Let's be honest here. So we'll be using them a lot, but only those metals. What that means is that if I throw a, let me see, where's my scratch paper? If I throw a Ba3N2, if I throw that at you, you're like, cool, okay, I know that is barium. Oh, I can't even spell. Let's get it together. Sabaka. Barium. And that's nitrogen. So you're like nitride. And I'm ready to put my Roman numeral in there. And I'm like reverse crisscrossing and being like, yep, nitrogen has a -3 charge. Okay, that means barium has a +2 charge. And you're like, barium 2 nitride. No, that is technically wrong. Well, it's not technically. It is wrong. And you're like, well, why? Barium does have a +2 charge according to this formula. Yeah, it does. It also has a +2 charge according to the group he's in. So if I give you anybody from group 1 or group 2 or silver, zinc, or aluminum, no Roman numeral for them. It's going to take your brain like a little bit of catching yourself to make sure you know where your metal is and asking yourself, do I need a Roman numeral for that guy or not? Because you will make some mistakes on the first time, especially when you're getting used to this nomenclature, and try to give these guys Roman numerals too, just because you're like ready for it, because you know this skill now in these transition metals. But that's something that we'll be practicing. So that's very exciting. So we've learned kind of all of the naming stuff. We've done just simple elements, metals and nonmetals. We've added some of our cute little polyatomic ions as options for us. They were not scary when we put them in parentheses. Now we've dealt with these transitioning metals, which are any of these metals that I've indicated in orange, meaning my D block, F block, and underneath the staircase, excluding silver, zinc, and aluminum, right? And we know that they need a Roman numeral to represent what its positive charge is. requiring that reverse crisscross to figure out what it is if I've given you the formula. The back page, page 4, is a mixed situation. But every single one of these ones on the back page, you guys, have a metal starting it off. Do not be afraid. Yes? They will also have a non-metal ending it, or a non-metal acting polyatomic ion. So for all of these things, you are just naming the things you see. You are crisscrossing the two things down, okay? Do not be freaked out. Go back to your foldable. If you get stressed out or overwhelmed, it will walk you through what you need to do. But this practice, and I have given you a lot of practice, is the key to getting this. And eventually you will not even have to think. But I understand there's going to be quite a bit of thinking required while we're getting started. But trust me that it will get easier. And I'm super excited for us to build up this skill together.